going on, everybody? It's Mr. Gustum in the physics conference room. Today we're looking at the difference between ohmic and non-ohmic resistors. So we have ohmic resistors, and we've learned about Ohm's law. So ohmic resistors are the resistors that follow Ohm's law. And so if I come over here to the whiteboard, Ohm's law is essentially that the potential across any resistor is equal to the current times the resistance at that resistor. This is Ohm's law. So any resistor that follows this, meaning as current increases, the voltage increases in a linear fashion with it based on the constant resistance, it would follow Ohm's law. And so we think about our ceramic resistors in class, those are ohmic resistors. Now we also have non-ohmic resistors which do not follow this rule. And this rule essentially states that as voltage and current, as current increases, the voltage through it increases, and the slope of this line is resistance. A non-ohmic resistor would deviate from that, meaning that either maybe as it's a light bulb, right, or something like that, as temperature changes with it, the resistivity of the material changes, and you might see some kind of like increasing in resistance because the slope of this graph is resistance and the slope of this graph is increasing. Something that heats up while it's operating might be an example of a non-ohmic resistor, or something that as voltage increases or as current increases, it doesn't follow this law. So less about temperature and more just about how the resistivity of the material operates at higher voltages or higher currents. So these are ohmic versus non-ohmic resistors. Today's lab, we're going to compare two. All right, we'll take some data on it and see how this works. So what I've got set up here in front of us is a ohmic resistor. And an ohmic resistor is our ceramic resistor. I'm going to go ahead and change the voltages from 1.5 to 3 to 4.5 to 6 up to 9. No, 1.5. I can't change the voltages exactly, so we'll have to go like 1. I'll tell you what they are. And then we'll measure the current. So because I'm controlling the voltage, I need to measure the current. Let's set up our multimeter so that it is in series with this resistor, and I can measure the current. So the first thing I'm going to do, I've got my green multimeter. Let's take these out. Let's change this to amps. And when I change it to amps, it always tells me what the heck I'm supposed to measure. So I always need something in the common ground, and it says I also need something there plugged in to the amp port. Now, in order to find current, current is the flow of charge through my circuit or through my loop. So I want to make sure that I get my wire to flow into the multimeter, and then the current will move through the multimeter, get measured, and then spit itself back out. So I'm going to break the circuit. I'm going to go ahead and make sure that the current leaves the power supply, enters my multimeter, goes across the multimeter, leaves my other wire, and is plugged back into my circuit, making sure none of these things are touching. So I've got my circuit now. I've got my high potential comes out, goes through the multimeter, into the resistor here, across the resistor, back to the battery. I am all set now. Get these light bulbs out of the way, okay? So here we are. You can kind of see my measurement maybe if I tilt it towards you, without the glare. That's gonna make it worse. Maybe I'll just do this. Is that gonna work? A little bit better, okay, right there. All right, so we're gonna start at 1.5 volts. I got 1.5 volts. When I turn it on, it gives me my measurement. So I got 0.14. So I've got 1.5 volts, 0.14 amps. Let's turn it up. We're going to 3 volts, 0.29. So now we're at 3 volts, 0.29. Now we are at 4.5 volts, and we are at 0.44 amps. 0.44 amps at 4.5 volts. If we're at 6 volts now, we go to 6 volts, I get 0.58 amps. That's 6 volts, 0.58. I'm going to try to finish this before we start to burn my table. It's getting kind of hot. At 9 volts, I get 0.88 amps. 0.88 amps at 9 volts. And then at 12 volts, is it 1.2? Come on. Oh, it's so close to 1.2. At 12 volts, I get a 1.17 amp current. 12 volts, 1.71. By the way, that's a 10 ohm resistor. Ohm's law. Turn that off before it starts to melt my table. That's your data. If you missed it, go back and read it, but it's pretty clear what's happening there, right? 10 ohm resistor, I've got my voltages 1.5, 3, 4.5, 6, 9, and 12. I'm going to replace this resistor now with a non-ohmic resistor. So I don't need to do anything to my setup. All I need to do is bring a non-ohmic resistor into the classroom. So I'm going to go ahead and set this up. Here's my Christmas light, or my holiday light, which is a non-ohmic resistor because of the fire inside and the resistivity of the material. So I'm going to leave it wave. I hope I'm not going to like blast this thing out of the water, but you can see it's on a little bit, but the brightness is going to change. The power dissipated across this thing is going to change as I increase the voltage. Let's see. So right now at 1.5 volts, I get 0.14 amps. Interesting. That's like pretty similar. It's acting like a 10 ohm resistor. At 3 volts, I now get 0.21. Interesting. 0.21. That's not what I thought I was going to see. There. It's acting a little bit more resistive. So at 3 volts, I get 0.21. At 4 volts, yikes, getting bright. At 4.5 volts. At 4.5 volts, I only get 0.26 amps of current. So 4.5, 0.26. Taking data. 6. It's like high beams in a car. At 6 volts, I get 0.3 amps. 0.3 amps. The current is not increasing much, even though the voltage is. At 6 volts, 0.3. At 9 volts, please don't burn this out. Oh my goodness, it is bright in here. Good morning. At 9 volts, I get 0.37 amps. Making sure you're reading this. And that's 9 volts over here, 0.37. Fingers crossed, children. Let's not burn this bulb out. Let's make it with one bulb. At 12 volts, it is. Oh, did I do it? I did it. I burnt the light bulb out. But you can see when I say I burnt the light bulb out, let's check and see what I mean. I mean quite literally. You can maybe see this. It is burnt. Like the edges are black. That fire in there, that current in there got too hot. Ow. You can feel it. And if you can look really closely, there is a filament in there that isn't there anymore. I literally burnt it out. Like it's trash. All right, well, there's your data. All right, this is the ohmic versus non-ohmic lab. That's your data. It's in the packet. Go graph the results of the data and answer some questions about ohmic versus non-ohmic resistors. If you got questions, drop them in the comments. Send me an email, ask me in class. Until next time, see ya.